In this video, we're going to solve a problem to find the volume of a solid using the integration. So we need to create a solid by rotating the region between these two curves around the x-axis. The first thing which we have to do, obviously, is to draw these two curves. So let me draw them. So we have to first of all draw the coordinate system. So here I would like to pick a couple of points. So this point is going to be 1/2, and this point is going to be 1. So let me draw first of all y is equal to the x squared curve. So when the x is equal to the 1/2, if I substitute this to here, y is going to be 1/4. So it's going to be 1/4 to here. So when the x is equal to the 1, it's going to be 1. Right? So if I draw this, this is going to be the parabola. Y is equal to the x squared curve. So y is equal to the x is just a line, the straight line between the 0 and the x, so 0, 0, and 1 point. So this is y is equal to the x curve. So I've got this region, and we have to rotate this region around the x-axis and create the solid, create the object, and we have to find its volume. So if we rotate, we're going to get this kind of curve. So let me draw this one more time. So we put the line to here. So the line is going to be like this to this side as well. Then also we have to draw this curve. Y is equal to the x squared curve. And this is what we obtain actually. So this is going to be very much similar to the cone. So let me try to draw this better. So this is kind of a cone, and this is kind of a cone where inside the cone is not a solid and is not empty. So it's kind of something, some object like there inside the cone. So I have to find this volume. So we are going to find the volume of this object again by creating the slices, the vertical slices. I have to just make a slice at some point, vertical slice at some point, and have to find the area of that slice. So let's do this. For example, if I choose this point, x is equal to the 1/2, if I have to create a slice, so this is going to be this kind of slice, right? So actually, the middle of the slice is going to be empty, right? So I've got a slice which is kind of a donut. So let's look to the slice in more details to here. So the slice is going to be a donut. So I've got a circle, and inside the circle I've got another circle. So this is what we get whenever we create a slice, and we have to find the area of the slice. In order to do this, we need to know the outer radius. So let me denote this as the big R, and the inner radius, the small r. So the area of this slice is going to be the area in between these two circles, and we can find that area by finding the area of the outer circle and subtracting the area of the inner circle. The area of the outer circle is going to be pi multiplied to the r squared, minus the area of the inner circle is going to be pi multiplied to the small r squared. So this is going to be the area of this kind of donut. So please note that this donut is going to be different depending on which point on the x-axis we're choosing. So for example, if we choose this point, x is equal to the 1, then you've got the two circles which are identical. So the radius of the outer circle and the radius of the inner circle are going to be the same. So, but if you choose some point here, for example, x is equal to 0.7, then I've got the bigger outer circle and also the smaller inner circle, so that the area between them is going to be very big. So let me redraw this here. So it's going to be a big circle, big outer circle, and a very small inner circle inside, like this. And so you see, so depending on where we are making the slice, we are going to get different different this kind of objects, different donuts. So what is important is we have to know how to find the outer radius and how to find the inner radius depending on our position on the x. For example, if I choose this point, x is equal to 0.7, what is going to be the outer radius? So the big radius. So this outer radius is going to be actually the y coordinate of this point, right? So I can find all the coordinates of the points on this line because I know the equation of this line, y is equal to x. So basically, if x is equal to 0.7, then y coordinate is also 0.7, then the outer radius is also 0.7, which is the y coordinate of the points, which is equal to the x simply, right? So we can write actually that the outer radius is equal to the simply x. Now, what about the inner radius? So for example, if I choose x to be equal to the 0.5, what's going to be this inner radius, the small r? So this is the y coordinate of this point here, right? So if I know the x, I can find the y coordinate by just substituting this to the second equation, y is equal to the x squared, right? So if x is equal to 0.5, then the y coordinate is going to be 0.5 in the square, which is going to be 0.25, which is the inner radius. So the inner radius is actually equal to the x squared, right? So our goal is to find the outer radius, then the inner radius, depending on x. If I just tell you, hey, if x is equal to the 0.2, 0.3, or any number between 0 and 1, what's going to be the outer radius and the inner radius? Then you should tell me the outer radius is going to be the value of your x, and the inner radius is going to be the value of your x in the square. So by knowing this, we can find the area of the donut at any point. So at any point, whenever we create the slice, we can find that area. So the area obviously is going to depend on the x. So this is going to be pi. If I take out the pi from the brackets, what I will have here is the r squared minus the small r squared. It's going to be equal pi multiplied to the outer radius as simply the x, right? Which is going to be x squared in a square. So minus r squared, the inner radius actually is the x squared. This is in a square, it's going to be x in the power of 4. So please note that x in the power of 4 is going to be always smaller than x squared if the x is between 0 and 1. So I've got this, the area function. So what I have to do in order to find the volume is we have to create a lot of areas between 0 and 1, and we basically just need to sum them, right? So I'm creating a lot of slices between 0 and 1, and by finding the sum, I can find the volume. So this is going to be, this is equal to the integration of the pi from 0 to the 1, x squared minus x in the power of 4 dx. So please note that I took out the pi out of the integration since it doesn't depend on the x. So the integration of the rest is going to be x cubed over 3 minus x in the power of 5 over 5. So we have to integrate this from 0 to the 1. Basically, we need to evaluate this antiderivative at the point 1 and at the point 0. So if I substitute the 1, it's going to be 1 over 3 minus 1 over 5. So minus pi multiplied to 0. So if I just substitute the 0, it's going to be 0 over 3 minus 0 over 5. So the second term obviously is going to be simply 0. The first term is going to be equal to, so we need to give the common denominator, it's going to be 5 minus 3 over 15, which is 2 over 15. So the overall volume is going to be 2 pi over 15. So this is the volume of this strange object. And we can find this using the integration.